okay, take a right-hand turn. And I couldn't do this in the middle of the road with the driver's instructor.
Okay, the piece we left off with yesterday was the intermediate value theorem. This is something that I think you saw in Algebra 2. We did it in college algebra. And we, at the time, were looking for like zeros of a function or x-intercepts. And we said if you have a graph and it switches between a negative and a positive value, so it's positive here, it's negative here, what's the only way to get from a negative to a positive? Well, you have to hit 0. And so that's what we were using it for. When we plugged something in, if one answer was positive and one was negative, we said, oh, the sign changed, so it has to be 0 somewhere in between these. The key, what we always took for granted at that point, we were graphing polynomials, and polynomials are all continuous functions. So this falls apart if I give you like a piecewise function and it's discontinuous in the middle. So the intermediate value theorem still works, but only under the condition that the function is continuous. So if I ask you to use this, you first have to verify that the function is continuous before you can use the intermediate value theorem. So if I want to show that there is a root of this equation, a root just means there's something I can plug in to make it equal 0. Okay, so we could try to solve this and find the actual number, and that would work. But I didn't even ask you what it was. I just want you to show that it happens somewhere. So a lot of times I might tell you, prove that there's a root between 1 and 2, or something like that. Since I didn't give you those numbers, we just kind of have to find some. So let's pick an x value. What could I plug in?
1.
1, 2. Either. Let's just start with 1. If you put in a 1, you get 4 minus 6. So we get 12. So what did we get? -1. Okay, so then what happens if I plug in a 2? So I get 4 times 8, and 6 times 4, plus 3 times 2 minus 2. 32 minus 24 plus 6 minus 2 is 12. So what we see is it switched from a negative to a positive. Is this a continuous function? Yes, it's a polynomial, so it's continuous.
Yeah.
So for the intermediate value theorem, you would have to just write a little statement for me. So you would have to say the polynomial is continuous. And you have to say it's continuous. If you don't, that's -1. And the sign changes. So a 0 exists between 1 and 2. So if you think about this on your graph, you had 1, -1, and 2 gave me 12. So the only way, if the graph's continuous, to get from those is by hitting 0. So for some x value between 1 and 2, I could plug that in and it makes the whole thing equal 0. All right. So what I want you to do now is go to that handout from last night, the last 2 questions. So it asks you to use the intermediate value theorem to show that there is a 0, and it does give you an interval. So when it says on the interval 2 to 3, what 2 numbers are you going to plug in? 2 and 3. And then you have to write me a conclusion statement. And in that conclusion, you have to mention the fact that it's a continuous function, because it's a polynomial, and you need to mention if the sign changes. That's what proves there's a 0. So take a couple minutes and do this. So we're looking at two different things here. Limits at infinity and how that applies to horizontal asymptotes. We have looked at infinite limits before, but not limits at infinity. Infinite limits were limits that we worked it out and we got the answer to be positive or negative infinity. A limit at infinity is like saying the limit as x approaches infinity, or as x approaches negative infinity. So if the x goes on forever, what's going to happen? So that is the first thing, just the definition. We have only looked at cases so far where x approached a certain number, but it could go to positive or negative infinity. If we look at some examples here, this kind of shows us, when I look at this graph, as x goes to infinity, the y value is just getting closer to this number L. Same thing here, and even here we have a wave, but as time goes on it's flattening, so it's still just approaching L. What are these pink lines called? Asymptotes. Yeah, those are horizontal asymptotes. So we've seen before when we had an infinite limit, so a limit where we approached a number and our answer was positive or negative infinity, that happened at vertical asymptotes. If we're doing the limit as x is going to positive or negative infinity, we're finding a horizontal asymptote. And if you remember in college algebra, we graphed horizontal asymptotes, but I just gave you rules. And I said, okay, if the degree on top is smaller, it's automatically y equals 0. And if it's the same degree on top and bottom, you divide leading coefficients. And you just had to trust me and memorize those rules. Well, it's because of the calculus behind it. So now we are going to learn how to use calculus to find those limits instead of just memorizing rules on when we have each kind of asymptote. So it can be positive or negative. This is just showing some that go forever in the negative direction, so same idea. And it's a horizontal asymptote in either of those cases. If you have a line that you're approaching as x goes to positive or negative infinity, that is the horizontal asymptote. It is possible to have multiple horizontal asymptotes, which is not something we ever saw in college algebra because we were only graphing rational functions. But if you think about inverse functions, one specific one, inverse tangent. So what inverse functions do is it flips the x and the y. And if you think about tangent, it had multiple vertical asymptotes. So when you do the inverse, it actually ends up with multiple horizontal asymptotes. So the graph of inverse tangent looks like this. We have one vertical asymptote as we're going to, or one horizontal asymptote as x goes forever in the positive direction, and we have a different one as we go in the negative direction. Most of the time, we are going to be looking at rational functions where we only get one, but because of these scenarios, we will have to check both. We'll have to check the positive and negative. A lot of times we'll get the same answer for both, but it is possible to get different answers. And this is the scenario where that happens. So first, I just want to practice looking at a graph and seeing if we can identify some of these things. So first, I want the infinite limits. So those are limits where you get positive or negative infinity for your answer. So are there any of those here? Yes. Yes. Those happen at vertical asymptotes. So we would have a vertical asymptote here and here. So I could say the limit as x approaches -1 is equal to what?
Infinity.
Positive infinity. Can I just do a single limit as x approaches 2?
No.
No, we would have to do the left and the right separately. So as we approach 2 from the left, if my x's are less than 2, where is this graph going? as I approach 2 from the right. So if my x's are bigger than 2, where is this graph going?
Mm.
So these are my infinite limits. And those infinite limits tell me which kind of asymptotes. Vertical. So my vertical asymptotes are at x equals -1 and x equals +2. All right. So then I want limits at infinity. Okay, so there's only 2 options here. You can have the limit as you approach positive infinity or the limit as you approach negative infinity. Okay, so as we go forever in the positive direction, is this flattening out and giving us a single answer? Yeah, what is that? 4. All right, as we go forever in the negative direction, what are we approaching? 2. So those are the limits at infinity. And they give me the horizontal asymptotes. Horizontal is y equals, so we have 2 horizontal asymptotes. Y equals 2 and y equals 4. Questions on that? So let's find each of these following. Different ways of doing it. Can you just break my chair? So we don't necessarily have a rule that says if we can just plug this in, if I have 1 over infinity, we don't have a theorem that actually tells us what it is. Let's think about a graph for a minute. 1 over x, I think we graphed that one a couple days ago. Can you plug in a 0 there?
No.
No. If you put in a 1, what do you get out? If you put in 2, if you put in 3, if you put in a half,
Oh,
2. You put in 1/3, you would get out 3. What happens when you put in negatives?
Negative.
Yeah, you get -1 gives you -1, -2 gives you -1/2, -3 is -1/3, -1/2, -2, -1/3. So you guys remember this graph? Okay. So what is the limit as we approach infinity?
0.
As my x is getting larger, my y is just going to 0 here. What about as we approach negative infinity?
0.
0. Okay. And this leads us to a very, very useful result. If you have 1 over x to a power, then the limit as you approach positive or negative infinity will always turn into 0. Okay, so we can think about it kind of using some reasoning skills too. We used it from the graph here, but just think about it. If I took 1, okay, and I want to divide it by 10, then you get a 10. But x is going to infinity, so x is getting bigger and bigger, right? So if I put in if I put in 10, I get 0.1. If I put in 100, what do we get out? 1 over 100, so 0.01. If I put in 1,000, what's happening to these y values? They're getting closer to 0. If you think about it, okay, if I buy a pizza for you guys, and you come in, let's say I cut the pizza into 6 slices, so you guys walk in, you each get a slice. Okay, I said, no, I'm going to add my next class in too. What's going to happen? I have to cut the slices smaller, so you're going to get less pizza. And then if I said, nope, I'm going to add my 8th hour in too, then everybody's getting less pizza. So the more people I add in, the less each of you get, so the amount you're getting is going towards 0.
Definitely just getting the equivalent of the elementary, like, school pizza party slice.
Okay, so does that idea make sense to everybody?
Yeah.
So if you have 1 over infinity or 1 over negative infinity, we can assume that goes to 0. This is going to allow us to evaluate some limits that we would not have been able to before. So if I gave you this limit, all right, if I just try to plug in my infinity, I get 3 times infinity squared minus infinity minus 2 over 5 times infinity squared plus 4 times infinity plus 1. Do we have any clue what that approach is? No. We can't even, if we just have infinity divided by infinity, we can't even really figure out what that goes to because it's complex. But in number theory, they talk about like degrees of infinity. And we're just saying it goes forever, but we don't know how fast it's getting there. So we can't just look at this and say, a really big number minus a not as big number minus 2 is going to go to this. We don't know that. But we know it's legal to multiply and divide the top of a fraction by the same thing, right? Top and bottom of a fraction. Okay, what is the highest power of x I see here? X squared. So here's what I'm going to do. I am going to take the top and bottom times 1 over x squared. Since I did it on top and bottom, it's the equivalent of just dividing by 1. So we can do that. So the limit as x approaches infinity. If I distribute that, 3x squared over x squared would give me 3. Minus x over x squared is 1 over x. Minus 2 over x squared. What's the bottom turn into? 5 plus. Okay. Just looking at this, it doesn't necessarily look better, but it is. Because we know limit laws, we can take this limit to each piece, right? What's the limit of a constant? So this is 3. What's 1 over infinity turn into? 0. 2 over x squared, that's just like 2 times. What does 1 over infinity squared go to?
0.
0. On the bottom I have 5 plus 4 over x, that's like 4 times the limit of 1 over infinity,
Sure.
plus 1 over x squared is going to go to 0.
Wait, why is that 0?
Because of the rule, anytime you have a number over x to any power. All right, so what does this give me?
0.
I'm just kidding.
3 minus 0 over 5 plus 0, so we get 3/5. Remember in college algebra, I said if it's the same degree on top and bottom, you divide leading coefficients to get your horizontal asymptote. And so we would have just looked at that and said 3/5. but now we know why.
Secret math.
Secret math, yes. Okay. So far, so good? All right. I want all the asymptotes here. So let's start with the easy one, vertical asymptote. How do you find that? Yeah, it's just what makes the bottom 0. So you get x to be 5/3. All right. For the horizontal, what we are going to have to do is check the limit as x goes to positive infinity and the limit as x goes to negative infinity. Like I said before, most of the time, you're just going to get the same number back both times. But there are cases where those two are different. So you have to check both, even though most of the time they'll match, sometimes they won't. So we have to do both. Okay, so let's start with just the limit as x approaches positive infinity. All right, so when I look at this, the strategy that we just used was multiplying everything by the highest power vector, dividing it. If I just plugged in 2 times infinity squared plus 1 square root of that over 3 times infinity minus 5, it makes no sense. Okay, we can't reason through that. So we have to use a technique. The bottom has an x to the first. Okay. The top has a square root. We know we have to multiply the top and bottom by the same thing. So for the bottom, I would need a 1 over x. That means I have to do 1 over x on top as well. Right. But I want to be able to bring this under the square root. 1 over x is the same thing as the square root of 1 over what? X squared. Does everybody agree that these are equivalent? Okay, we're going towards infinity, so x is a positive number, so we don't have to worry about that. So on the top, instead of just doing a 1 over x, I'm going to do the square root of 1 over x squared. They're equivalent. If I simplify it, I just get the 1 over x. But I want the square root so I can bring it under my radical. Okay. So 2x squared times 1 over x squared. That would be a 2. Plus 1 over x squared. On the bottom. 3x times 1 over x minus 5 over x. All right, does this help me? Yes. Essentially what you can do now, we can evaluate the limit. So on the top we have the square root of 2, 1 over x squared would go to 0. Anytime you have a number over infinity, it turns into 0. So the bottom would be 3 minus 0. And so we get the square root of 2 over 3. So that means we have one horizontal asymptote we found so far.
The other side.
But we're not done. We need to do the other side. Okay.
So the other side is very similar. But we're doing, as x approaches negative infinity.
So, to start, we can't do anything until we kind of get this to be more reasonable. So we need to try to do what? What did we do first last time?
1 over
Mhm.
x. Okay, now this one is slightly different. Here's why. As x is going to negative infinity, 1 over x is what kind of number? It's a negative this time because we're going to negative infinity. So I'm like plugging in -5, -6, -7. But when I square it and do the square root, what kind of number am I getting? Well, since you squared it, it'd be positive. So this side right now is negative. This side is positive. If I want them to be equal, what do I need to do over here?
Add a negative.
Add a negative. So we have a negative square root of 1 over x squared, so that those two things are equivalent. So that negative can just stay out in front. 2x squared over x squared is 2, plus 1 over x squared. On the bottom, we get 3 minus 5 over x. So now, if I plug in my infinities, we have a 2, 1 over negative infinity squared. Anytime you have a number over infinity, it turns into a 0. On the bottom, you have 3 minus 5 over infinity is 0. So this time we get a negative radical 2 over 3. So this one has a second horizontal asymptote. Y equals negative radical 2 over 3. And that's why we have to check both positive and negative infinity, because sometimes the answers do not match.
So where does 0 come from? You just plugged in 0 for x?
Anytime when you plug in the infinities, if you have something divided by infinity, a number divided by infinity, it will always go to 0.
Okay.
So, we are not done. We're spending the rest of the week on this. I am going to stop here today. If you look at your last slide, okay, I have the homework on here. This is the assignment that is due on Monday. So this is all of your homework for the week. You could start this if you wanted to. You could really do quite a few of them. I mean, depending on how, you could potentially even go up through 23 right now. I don't know that you really want to, but you've got a little time, so you can get started on this. So to start this assignment, it is due Monday. We'll spend the next 2 days wrapping up the notes